In chapter 13, we're going to do some graphing. So we need to review a lot of different graphing from both like Algebra 1 and Algebra 2, just to make sure we're all on the same page. So first thing is to know that you can always just plot points to make a graph, right? That's never a wrong thing to do. Even if you know something about the graph, you can still plot points just to check yourself. So that's what we're going to do. It says make a table of values and then graph the equation. All right. So table, we always put x's. We pick some x's to plug in, and then y is whatever equation they give us. In this case, I'm seeing a fraction. So we just need to be smarter than the fraction. And in this case, what that means is I want to plug in numbers that are divisible by 3. Because of this negative 1/3, we're going to use x values that are divisible by 3. Because all 1/3 is it means divide by 3. So the x's I'm going to plug in, maybe I'll do a -3, 0 always works, +3, maybe a 6. Because we can pick any x values we want. So if we see a fraction, let's utilize that. Another thing we might, want to know ahead of time is what kind of graph should we expect from this? If I see x to the first power, what that means is that this makes a straight line. Whereas like in the next problem, when we see an x squared, what that means is that this is going to make a parabola. So just knowing some things about like what x to the first power does, it's a straight line, x squared makes a parabola, can also help us. But we're just going to plot some points. In this case, they didn't give me any axes, so we better get a straight edge. Now that does not have to be a ruler. A straight edge can be the side of a notebook or, I don't know, side of your phone. I know we got that with us. Whatever that looks like for you. But I'm going to try to make these lines look decent. And I do want you to use straight edges for these. So, pause the video, go get, a side of a notebook or something that you can use to make some decent lines. Okay, so when I plug in -3, I'm going to replace x with -3. So that's -1/3 times -3. And then I'm going to, of course, add 4. So -3 divided by 3 is 1. Those basically cancel, but a negative times a negative makes a +1. So this would be 1 plus 4, which is 5. And you could also use a calculator, but I picked -3 so that this 1/3 would cancel. 0 times anything is just 0, so it doesn't matter that it's 1/3. 0 plus 4 is 4. All right, let's try -1/3 times +3 this time. So the 3's will cancel, and we're left with -1 plus 4, which is 3. All right, finally, -1/3 times 6 plus 4. Well, 6 divided by 3 is 2, but this makes it a -2 plus 4, which is 2. So just remember 1/3 just means divide by 3. So 6 divided by 3, make it negative. And then add 4, of course. All right, so let's plot these points. Hopefully I don't know, put my axes in the right spot. We can also, make each block be 2 if we wanted, but I think it'll work to make each block be 1. So I'm going to go back 3 to -3, and then up 5. 1, 2, 3, 4, 5. So that's the first point. -3 for x, 5 for y. Next point, when x is 0, we go up 4. When x is 3, 1, 2, 3, we go up 3. And finally, when x is 6, so sort of towards the end of our graph here, we'll have a y value of 2. All right, we're going to use our straight edge, make it look pretty. Let's see. Oh, look, they make a straight line, because anytime x to the first is the highest power, that should make a line. Okay, well, let's try the same thing, but this time with a parabola. Nice thing is we don't have any fractions. So when you don't have any fractions, that means you can really plug in any x values. 2x squared plus 4. I mean, we want x values that are on our graph, so I don't want to plug in 100 probably, but I could, right? First, let's make some axes. So I'm just gonna make it clear like where I'm starting this graph. It doesn't have to be in the perfect center. I'm not sure why this didn't have axes already drawn, but it does show that like we can draw our own axes too. We can handle it. All right, so when there's no parabolas, I'm just gonna do like -2, -1, 0, 1, and 2. At least for a starting point, and then we'll see if we want more than that. All right, so in this equation, PEMDAS says we're gonna do the exponent first, then multiply, then add. So it's -2 times -2 squared. -2 squared, oh, and I better add +4. -2 squared is +4. -2 times +4 is -8. +4 makes -4. All right, let's do the same thing with a -1. -2 times -1 squared. -1 squared, if you're typing it a negative to an exponent in the calculator, you better be using parentheses. Otherwise, just do it in your head. -1 times -1 makes +1 times -2 makes -2 plus 4, which is 2. 0 is a lot easier because 0 squared is 0. 2 times 0 is 0. So this is just 0 plus 4, which is 4. Okay, let's try 1. -2 times 1 squared plus 4. Oh, well, 1 squared is +1, so we end up with the same thing as -1 because parabolas are symmetric. So this would still be -2 plus 4, which is 2. And then when we plug in, oops, still make the leading coefficient negative. When we plug in the +2, 2 squared is 4 times -2 makes -8 plus 4, which is -4. All right, so we get some symmetry because it's a parabola, but let's plot these 5 points. So we go over where x is -2, the y value is -4. So -1, 2, 3, 4. Here's where -4 is. Plot that point. When x is -1, the y value is now +2. When x is 0, we go up to 4. And then it's symmetric on the other side. So like when we're at x equals 2, we go down to -4. Now, parabolas are not as easy to draw because we don't have a straight edge. Don't make it look like it's a V. Try to make it look, rounded-ish. We should also be drawing our graphs down to the ends of the axes, right? On this one, you may have noticed I extended that line. I want you to extend lines and not just like connect the 2 points, but really make it look like it fills the grids that we made.